Hello, thank you for coming to my talk. First of all, I want to say thank you for organizer for such opportunity. I think it's something new for a lot of us. And yeah, let's start with the talk. Let me share my screen. Yeah, today we will talk about building Android application with Jetpack Compose. Jetpack Compose is something new which was announced recently. And during this talk, we will talk about basic of Jetpack Compose. And later on, we will try to build Android application step by step. When we finish with base implementation, we will talk about routing, typography, theming, and some additional features which Jetpack Compose provide to us. But before speaking about Jetpack Compose, I want to start with history of Android UI. First release of Android we had in 2008. It was Android 1.0. And starting from this time, we use XML file for creating user interface. Of course, we can create it with Java or Kotlin code, but most of the time it's XML file. I personally started before Android Studio, and we use Eclipse with SDK and plugin, but unfortunately, sometimes plugin doesn't work very well. And with Android Studio, and especially right now, everything worked pretty well. The next big release was a year ago after Android Studio. It was release of Recycler View. And I hope right now everyone use it. And it's working well. But before it, we had list view, we had list limitation for scrollable data. And as a result, we had some problem with scrolling. So the next big releases was constraint layout and support design library. We had it in 2017, and this was two super important releases because the main problem of Android that UI Toolkit was built into Android, and the whole Vue framework was bundled in Android. And speaking about design library, in this time, in 2017, we already know something what is called material design, and more developers go to material design. And in this library, we had components like snack bar and many other text layout, input, etc. And constraint layout, I think right now familiar for everyone. And a year after it, we have material design component. And it's also pretty huge milestone for everyone who work with Android development, because almost all applications based on material design. And last year we had release of Jetpack Compose. Right now it's in developer preview version, and today we will talk more about it. However, before speaking about Jetpack Compose, I want to come back to the Vue framework. Vue framework was created more than 10 years ago. Of course, right now it's a lot of changes, a lot of improvements, a lot of new approach like Vue binding. But for any technical decision, you can have drawbacks because for a small sample, everything worked perfectly. But speaking about a tool which used by million developers, of course, we have some drawbacks. And I want to start with such drawbacks. So the first problem is that UI framework was built in Android. Right now, we have few more updates from vendors. But 5-7 years ago, very often it was pretty usual case when you buy a phone and you have no update at all. And speaking about it, of course, if you had some problem with Vue framework, you should wait new release for fixing this issue. Or very often different vendors provide custom UI. And when you try to have similar UI on different devices, it was very complicated. The next big issue connected with the first one, that UI framework binded into Android operating system, is that we often have fragmentation. And sometimes you can have some methods, and all this method from text view class. And sometimes you have a situation when some version of IP available only from some version of IP. And of course, it was a problem because very often when you start develop something, and you should have two different implementation for different devices. And of course, it's not ideal situation for development. The next kind of issue is that Vue framework use inheritance. And if we take a look at example of this button have possibility like select text on the button. And it's unfamiliar behavior for Android development. And of course, it can be tricky. And the main reason of this problem is that button extends text view. And text view have such possibility. And it means that all developers should know which properties, functions, etc. you should use and which you should avoid because it's of inheritance. And of course, if you take a look to amount of this file, as example view, it's more than 29,000 lines of code. Text view is also super big. You can see that it's super complicated to maintain. The last problem from my perspective is code duplication. Because when you start working with creating custom views, you always should write for fully similar constructor, except class name. And of course, you should just increase amount of code. And it's a real example of checkbox. Because here we extend compound button extends button extends edit view, and edit view extends view. It means that in checkbox, we have all possibilities from all these classes. And of course, we don't need such possibilities. And of course, in some cases, it generates some problems. So let's move and speak about Jetpack Compose. Jetpack Compose, it was created fully from scratch. It's not based on Vue framework. We have interoperability. We will have interoperability because right now we don't have it in developer preview yet. But let's speak about the main features of Jetpack Compose. And the first feature is that it's fully unbundled from Android. It means that it's distributed as a separate libraries, not only libraries, we will talk about it later on. We will have interoperability with Vue framework, and right now we should have Android Studio 4.1 or higher. Right now, the latest release is 4.1 beta 5. So Jetpack Compose, it's combination of runtime. For it, we need Android Studio, because in Android Studio, we have injected plugin, which provide preview functionality for composable functions. We need a plugin and compiler. Right now, it's a bit different from the last release of Kotlin, but I think later on, finally, it will be unified. And we have set of UI libraries for framework, core libraries for animations, for testing, etc. So let's take a look at the first example. It's a very simple example. And here we will try to build a calendar item for showing date. And first of all, we need to create a function, and our function should be composable. For making any function composable, we need to mark our function with composable annotation. Later on, we want to build a circle. And the best one of good choices for building a circle on the background is surface. Because for the surface, we can predefine size and shape. Of course, color and many other modifiers. So later on, we should center all our items, and for it, we can use box. It's something like a container. And later on, we start using our layout. Its first layout, it's column, And with this layout, we just placed all items in a column. And in a column, we place text with a short version of months, text, another text field with date, and the last one text with a month. So, as I told before, we can use preview functionalities in Android Studio. The really cool stuff that we can create as many preview function, and Android Studio will render all this function. Of course, if we will use more and more such functions, we will use more and more memory. Android Studio will use more and more memory. As you can see, preview function is usual composable function with preview annotation. As example, in this case, we have two preview functions. First function show just one calendar item, and another function show two calendar items with some space between them, and they're placed in a row. As you can see, when you create one composable function for, as example, calendar item, if you have problem with slides, you can download slides in description. I hope it will be fixed. I hope connection is also good. So we can combine multiple composable function and place it in a different way. So let's try to extend this sample. Right now, calendar date is composable functions which we discussed before. And this function will render only one item. And we can use a repeat function from Kotlin. And we can wrap it into row layout. And as a result, we can have 7 days of a week. Of course, right now, date is fully the same on all these items, but main idea of this slide is to show power when we combine in Jetpack Compose with a Kotlin possibility, even such simple as a for loops. And later on, we have 1 week, and we can render multiple calendar weeks in a column with a column layout and wrap it into calendar. As a result, we can pretty easy render our whole month of 4 weeks. So right now we discussed a bit how we can create composable function. But of course, composable functions should be connected with activity, because activity is main entry point of the application. And speaking about activity, of course, we can just attach to activity or to the fragment. And here you can have basic samples how we can attach it. For activity, we can just use setContext function and add composable function. Pretty similar case we have for fragment. It's a bit complicated. Later on, we will talk about routing, and we'll discuss a bit more possibilities which we have with Jetpack Compose. So we should understand that composable function is something fully different which we have in a Vue framework. Because when we speak about Vue framework, very often we use functions like set visibility. And sometimes we had situation when in 10, 15 places, we just use set visibility. And of course, it was complicated. It was super easy to have some mistake. But right now, composable function will recompose itself when data changed. But if you want to have possibility provide possibility to Jetpack Compose for recomposition, we should use trackable types, and data should be wrapped in trackable type. And we have two trackable types. It's model and model list. So let's start with a model. A model is a simple annotation. We generate additional code under the hood. And we can create usual data class, and our counter model class will store inside count. And this counter object will be passed into our counter composable function. And later on, when data will change, as example, when you press plus or minus button, data in this type will change. Compose tracks this function, and composable function will be recreated. It means that for us, using Compose, the most important is thinking about data. When we think only about data, Compose will do a lot of stuff for us. And model list is used when we want to track list of data. Because with model, we can track only one object, and with model, we can track multiple. We can track changes in this object. We can also track amount of such object in a list. And it's very important because model help us to solve a lot of problem with which we have with Jetpack Compose. It's not a problem, it's like a solution, because model class, it's really a solution for almost everything in Jetpack Compose. So let's talk a bit about layouts, because layouts is something very important when we design our UI. Right now we have 4 different layouts. It's row, column, stack, and constraint layout. So if we combine row and columns, we will have something similar to the linear layout. Stack allow us to locate elements based on gravity, and constraint layout, it's probably right now a bit simplified version of constraint layout because it's still in developer preview. So let's talk about row. As you can see, all Jetpack Compose code looks like a DSL, domain-specific language, and in this case, we will place 2 composable functions because image and text is also composable functions in a row. And we should wrap image and text with a row function. If we want to place them in a column, we should replace row annotation to the column. Of course, like with linear layout, we can have row inside column, etc. And let's move to the next structure. It's a stack. And stack, for stack, we need to always use gravity. It's a really powerful tool, but we should understand that we never will use only stack because it will be super complicated. As example, if you try to place latte text in the middle of a screen or the stack box, because in this case it's have predefined size, probably it will overlap with an image, and of course it's a problem. But if we combine few layouts, it will solve this problem, and we will have powerful of the stack layout. So speaking about constraint layout, it's what we have right now, and with constraint layout, we should understand that everything split it into 2 different groups. First of all, it's constraint set, and here we have all our constraints and our implementation. In our implementation, we can use other composable functions like images, text, buttons, and much more. And we should use modifier and tag modifier. Tag modifier will link our constraint and the current composable function. And all tag can be linked by string, and I recommend to extract it to the constant. And when we will build an application, we will talk about it with additional details. And here it's basic application which we will try to build, of course, with some not whole application, just part of it. Because its whole application is pretty big and we have not too much time. However, you can check a link for GitHub repository. It's built in. I trying to regularly update and add more and more feature to this project. And this application is pretty basic for Android. It's use master detail flow. And I choose such application because when we think about any framework, we think about basic scenario. And if you open many Android applications, they will look more or less similar, and for sure will use master detail flow. So this application also supports different themes and different types of the card. It was added just to increase complexity, and complexity is needed when we want to learn how this framework works, and if this framework powerful enough for our everyday work. So let's start with a simple list item. For building list item, we need to create a model. As you can see, it's a simple data class with model annotation. And let's create composable function with one parameter. And this parameter will be object of our model class. So I propose to build different composable functions with different approaches. And for this approach, I propose to use row and column layouts. And for the next screen, we will use constraint layout. I think it just provides more understanding how it's works. The first step, which I want to go, is to split whole our row into 3 base components. First component is an icon, and it can be 72 to 72 dp. The next component should use all available space between our icon and favorite composable function. For it, as in linear layout, we can also use weight and place it between 2 different boxes. Of course, boxes is not really needed in this case, but I think it will be great. It will be great starting point. The next part is let's try to build our UI component. And for UI component, I mean icon. So we have icon and icon on top of circle. First of all, we need to build a circle, and for it we can use familiar for us surface composable function, and we can use shape circle with additional paddings. It means that height and width of this function is 72 dp, and if we extract 16 dp, we will have an image 40 to 40 dp. And here we can use image function with painter, and this painter will use link which we have. All these icons which we use, available in project. If you download it from GitHub, you will have all these icons. Right now it's pretty basic implementation. However, later on I plan to add to this project much more features and attach backend to it. So the next component, we should use box because we don't have really predefined size of it. We want to use weight property to spend all available places between icon and favorite state. And inside this box, we can use column with title and some list of ingredients. And very important note here, and very powerful, that we can use modifier draw opacity for the ingredients list. Because when we will talk about theming, we should provide theme for different colors for different themes. And of course, in both of these cases, we can use black color, but for ingredient, we use black color plus opacity, and it doesn't look like a pure black color. And the last part is our favorite icon. And I propose to use as it's a toggleable object, which can have 2 different states. A toggleable object is toggleable function. It's predefined function in Jetpack Compose framework, and we can use it. And based on the state, we can use different icons. So based on these icons, we can use 2 different icons. for favorite and not favorite. And toggleable features will help us just to switch the state of this from this icon. And when we know resource ID, we can just pass it to the image for rendering. But if we try to place everything in one composable function, it will be pretty long and completely unmaintainable. So what I propose is to try to split this function into small functions and have something more maintainable and readable. And finally, we can create a few additional functions. When we can place items in a row, it will be logo, additional information with title and ingredient inside, and a favorite. And of course, speaking about additional information, it will place all children in a column. And based on this pretty short implementation, I think it's pretty readable. And if you know that something wrong with your logo, you should go to the logo composable function and just fix it in one place. And don't think about reading and maintaining whole stuff of whole pretty big composable function. So right now we have all our items. And what is our next step? Our next step is to put many items together. And for creating a list of items, we can use adapter list, which has a mandatory parameter. It's a data. It's a list of any data which we want to show. And later on, we can use our function. We can put our coffee drink list item function as a composable parameter. It's usually the last parameter. And if you want to make it clickable, we should wrap it into clickable composable function. And another really cool thing about modifiers is that when you use modifier and you want to add ripple animation, you can just use ripple modifier. And that's all what you need to do for having ripple modifier. But if you take a look at this list, for me personally, it's missing a divider between all these items. So let's try to create another composable function with a divider. And when we need a divider function plus modifier. In general, modifier is something super powerful in Jetpack Compose because we have modifier for a lot of stuff, for opacity, for drawing background, for padding, for size, for weight, for many more stuff. And modifier is super important, and it's really great to know many modifiers. So, but if you want to place our divider below our item, we can use column layout. And as you can see, we can place in column layout divider below the list. And after each element, we will have a divider. So right now we have list of items, and the next step is to add is to have toolbar. Toolbar familiar for us from traditional approach of building UI. And in Jetpack Compose, we have up bar, and one of up bar implementation is top up bar, which is for us will be replacing like a toolbar. And we have few different implementation of top up bar, but for us, we will use one of them with title and actions. And really good and power of Jetpack Compose is that it's super generic. If we take a look at title, title doesn't have a string as a type for provided title. Inside, it has composable function. If it's composable function, we can customize it. I think it's if you try to have custom layout for toolbar, it's a bit tricky. And with Jetpack Compose, it's super generic and it's super you can create one composable function and put it into another composable function. And if you want to have some actions or menu items, we should add them to the action, to the actions parameter. In this case, we have only one action button, icon button, but we can have many of them. And I want to show a little bit trickier example. And here, I want to propose introduce status data class. And the status data class will be like switch between normal list item and detailed list item. And of course, we will have two different icons. When we have a short list item, we can have icon of a detailed list item in up to top up bar. But when we have detailed list with detailed items, we can have icon of short one. And it's super easy to implement because we can use Kotlin as a programming language. And in this case, we can just use if and check current value and current state of is detailed item value. And based on it, we can load proper icons. As you can see, we have additional benefits by merging UI plus power of programming language. And the next screen, I want to propose to build with a constraint layout. As we discussed before, for constraint layout, we have two blocks. First block, it's constraint set. Of course, we can use modifier and much more options, but constraint layout, it's something which is mandatory for constraint layout. So first of all, I propose to start with creating a constants for tags because we should connect our constraint set and our building blocks. So when we created a constant, we should create an object for constraints. And when we created as many objects as we need, as many UI items which we have on the screen, the next step is to add this, attach our constraint to our composable function. And when it's done, we can do it also with modifier. And when it's done, we can add our implementation for each component. As example, in this case, surface will have left, top, right, and bottom constraints, and all these constraints will be connected with parent. Of course, we can connect them with not only with parents, with any other constraint. But in this sample, I just want to show you that we have such possibility. So I want to show a bit more trickier example, and which also demonstrate a possibility merging Jetpack Compose and Kotlin as a programming language. So let's create a simple substring data class, which has two parameters, its string and start position. And under the hood, we can easily calculate end position. Later on, we can get name substring and another coffee names substrings. And later on, we can create annotated string. Annotated string allows us to customize our text. And for customizing our text, first of all, we should add our text to the annotated string. And later on, we can use styles. And for applying styles, we need to know start and end position. That's the reason why do we need a substring data class. And later on, combining them, we can have something which we have on the screen. That name of coffee in description have one style, but a list of other coffees or coffee drinks will be have italic and underline style. It also right now possible, and you should do it only in your component. You shouldn't do it in different places, because right now, if you want to have something like this, we should define XML in one place. We should do some recalculation and style changing in our application code. And right now, everything you can have only in one component. So let's take a look at routing, because routing is super important part of any application. And here we have few options for building application with Jetpack Compose. So first option is to have one Jetpack Compose screen into one activity. And if we want to navigate between these activities, we need to use start activity and just go with traditional approach. You also can change a bit this approach and apply it to different fragments when every screen is different fragment. So another approach, more natural, I think, for Jetpack Compose, it's also to use crossfade function. Crossfade function allows us to switch with small animation between two different composable functions. And in this case, whole our screen, it can be composable function. But if you want to use have switch between two different composable function, we should create another model object, and this model object will have current screen, and screen it's composable function in our case. And later on we can define many screens in one place and create a simple function which will navigate. In this case, upstated will be something more or less global. And the last step is to use crossfade function, and it will be another composable function. And what is really cool that it also will be recomposed when data will be changed in upstate. That's why I told that model is super powerful. Whole conception with model and trackable object in composable function, that if we only use composer, if we change the data, whole composable function will be redrawn. It's super powerful, and right now we need to think only about data. So let's talk about theming. This application support two different themes. It's light and dark. And let's take a look and talk a bit how we can implement it. So whole idea of Jetpack Compose, speaking about the themes, it's based on material design guideline. If you open a material design guideline, you can see a lot of predefined colors. It's primary, secondary, background, surface, and much more. And all these colors can be split into two different categories. First category is color of the composable function. It's if we have composable function, this function can have some background or outline or text color, etc. And all colors which start with on connected with text. And all these items will be, as example, on primary means that it will be rendered on top of primary color. In this case, we can easily understand about which colors we understand, because everything what starts with on more or less connected with text. And when we created such color palette, of course we can create multiple of them. And later on, all this we have material theme composable function, and this composable function is usually root placed in a root composable function. However, if we use multiple preview functions, you should also place it in preview function, because preview function should use the same theme as your whole application. In this case, If you want to understand which color to use, of course, if we have more than two, and these two not connected with global settings of our device, we can use another model class, or if we want to synchronize it with global setting of device, we can use eSystem in dark theme. And using basic if, we can choose color palette as in this example, and later on put it into the colors. In this case, we can apply theme into our composable function, preview function, or even for whole application. But sometimes when we define, as example, typography, and we will talk about it later, it's connected with font. But we want to customize it and have custom color, we can use just copy object, because typography and color theme returns a version of text style. And sometimes we want to combine few of them. And in this case, we can use copy function and customize additional parameter, which is needed for us. So let's go to typography, which is also super important topic. I very often had a situation where sometimes in a pretty big project, fonts should be applied to each component for each edit text or text view as example. And very often it's super easy to forget apply just one UI component. And new approach with Jetpack Compose, I think a bit more generic in this case. First of all, we need to define all fonts which we have in application. And we should create a font family object and add each font. For each font, we should define resource ID. Of course, it should be added to the resources. Weight of this font, which usually such information can be found on the website when you download your font. And style, it can be normal or italic. When we define it, the next big step is to create typography object. Speaking about typography object, we have few different predefined set for typography. It can be from H1 to H5, body 1, body 2, button, and much more. And all these names defined in material design guidelines. And right now, it's super cool that developers and designers have only 1/3 of true, which is material design guidelines. And when developers and designers speak about, as example, H2 tag, both of them understand it in the same way. And from my perspective, it helps us to solve a lot of problems. So how can we apply our typography? We can apply them to material theme composable function together with colors, also to preview colors, and later on we can just use it as a style, material theme.typography.h5, the same as with color. And if we want to merge them, I mean typography and colors, we can do it with copy function. So, of course, it's only a small part of Jetpack Compose, but we have much more functionalities like testing, animation, and I tried to add the most interesting question which very often people have when we speak about Jetpack Compose to this section and try to cover it a bit. So, resources in Android, it's a super powerful mechanism. We can use it for, as example, translations and much more. And of course, we can use it with Jetpack Compose because I think everyone agrees that it's super powerful mechanism for storing colors. Right now, we can store colors. Probably later on, we will try to avoid it. But string, images, maybe some additional stuff like XML file and much more. Of course, we can use them. Both of this function under the hood use context ambient, which provide context and inside this application, under the hood, Compose provide context, and based on this context, we can work with, as example, string resources. Right to left, it's also supported, but I think in the future it will be supported even better, because few releases ago it wasn't supported at all, and right now we have such possibilities. Because it's a developer preview and we have new releases every 2 weeks. And for each release, we have more and more features. The next big thing is testing. If we try to analyze screen, which we have with Jetpack Compose using Layout Inspector, we can see only one view. It's called Composable View, because all composable code rendered to the canvas. And of course, for Espresso, it's one big issue, because Espresso work based on view hierarchy. And here it will be super complicated to find anything connected with view hierarchy. And for it, together with Jetpack Compose as a separate library, provided right now small test framework. And in this framework, we can use composable rule. We can create a composable function like launch screen with some parameters, and with also a few more asserts, like assert is displayed, assert is hidden, and much more. And we can find text by find component by text, as example in this case, and we can write even right now some small UI tests. And we will have interoperability. Right now it's not available, but in future we will have generate a view annotation. And together with this generate view annotation, when we will use this annotation during compilation, our composable function will be converted to the whole class with for the view framework, and it will be generated a view, which can be used in XML file and of course in a code. Information about it I found in Google I/O, one of Google I/O talks, and it will be provided in future. So, and right now we have a lot of components which was created from scratch, as example, adapter list, layouts, text, button, and much more. However, two UI components wouldn't be created from scratch. It's component for rendering map and for rendering web pages, because right now everything should be rendered on canvas. And of course, when we use maps, for us it's very important to use OpenGL, etc. And for maps and views, we will use native components with some wrappers for Jetpack Compose, which will simplify work with it. And right now we have whole library for animations. It has from release to release more and more features. And even right now we can create pretty great animations. And the biggest note is that right now it's in developer preview. I don't recommend use it for production right now, because if you take a look at this GitHub repository, you can find that sometimes between changes, you need to rewrite pretty big amount of code, because in easiest way, one of composable function or modifier will be marked as deprecated. But sometimes you have the situation when component was just moved to another package or renamed or was extracted to separate library and your code just not compiling. Fortunately, you always can ask such questions, and of course you can read release notes. In addition to it, you have official Slack channel of Jetpack Compose, and you always can ask questions on this channel. And that's all my story about Jetpack Compose, about how can we implement Jetpack Compose with, how can we implement Android application with Jetpack Compose. If you have any questions or want to read more about Android development in Jetpack Compose, I encourage you visit my blog, visit Twitter, and if you have any question, If you have any question, just let me know. Let me to share link. Oh, link was already shared, and I hope we have some questions. Thank you for your feedback. So let's take a look. To our questions. Yeah, I start reading question. And first question: can you move into Compose gradually? Only part of the screen, a single custom view, or does the whole activity fragment content need to be composable? And answer to this question, it's a bit tricky, because when we will have interoperability, and as example, we will convert, we can have the situation when we can write composable function and convert this composable function into the view framework. It will be a bit simpler. But right now, if you want to move to Jetpack Compose, you should create fully new composable function for the whole screen. And later on, using setContent method, apply this composable function to the screen. And the next question, how do you feel about building and maintaining complex layout comparing to XML? Is it harder, easier, or simpler? For me personally, it's simpler. I really like this approach because first of all, right now we have everything in one place. Because very often we had a situation when part of implementation we have in XML file, and another part of implementation we have in our Java or Kotlin code. And right now we have all in one place. We can create pretty small composable function, which will be easy to maintain. As example, as I showed in presentation, when we built divider, and divider had the same space as icon. And if we create a constant for it inside the component, we can easily use this constant into a few different places. The same with composable function. If it's something super generic like favorite composable function, you can use it in many different places. Yes, let's go to the next question. Where should we create themes and style with Jetpack Compose? It should be created as a separate file. You can check link in GitHub repository. I personally created it in near activity. Of course, you can place it in any place, because later on you will use import for having access to it. I personally extracted it into different places, into different Kotlin file, and in this Kotlin file, I defined few themes for the dark and light colors. So let's move to the next question. Does Jetpack Compose have limitation? In your coffee detail view, how to introduce a parallax effect at scroll like the provided by coordinator layout. The really cool news, which was announced probably a week ago, that for Jetpack Compose will be created, ideally they want to create, developers who release Jetpack Compose from Google want to create this fully featured constraint layout and motion layout. And with motion layout, it's super easy to implement animations for scrolling and much more animations. Right now, it's on pretty early stage because developer preview, it's something like pre-alpha. And speaking about pre-alpha, right now it can be a bit more complicated. However, you have transaction and animation, and you can implement it. But in practice, in future, it will be much simpler because powerful tool like fully feature constraint layout and motion layout will be supported by Jetpack Compose. How can we use different dimension resources files in Composable? In practice, why in Android we used dimension resources? First of all, for extracting constants, and right now we can move these constants into Kotlin file inside components or have a separate place for them. And another one for supporting different devices. And speaking about supporting different devices, right now we don't have a solution for it. However, we have all information about device because it's still Android infrastructure, and we get all required information, from the Android ecosystem, and just use it and create some function for understand if it's tablet or not tablet. As example, when using model annotation and changing the model's value, how can prevent that the whole UI will be rebuilt? The really cool stuff that it's a trackable object, and if it's trackable object, Jetpack Compose know what was changed. And Jetpack Compose change only a part of UI which should be changed. All other stuff wouldn't be redrawn. The only part we changed based on data will be redrawn, and it simplified our life a lot. The next question: can we test with Espresso and activity created with Compose? Yes and no. Yes, we can test activities, and no, we cannot really test Jetpack Compose composable function, because speaking about Jetpack Compose, everything rendered into the canvas. And right now, Espresso testing based on view hierarchy, and right now we don't really have a view hierarchy. But as I showed a few slides ago, we have a special component for achieving this UI testing, and it's working also pretty well. Does Compose work with accessibility? Right now, as I know, Compose doesn't work with accessibility, but you should remember that it's pre-alpha. I think it's not the most important topic for a developer team right now. As I know, it's not working right now, but I think maybe in future releases we can have such possibilities. So the next question: box, row, and column. It's difficult to see how this approach is compatible with constraint and other view groups. Box, it's row and column. It's layout. It's a layout, and this layout helps us to place elements in row or in column. However, box, it's something like a wrapper, and inside this wrapper we can place much more composable function. Yeah, it's the main difference that row and column it's a layout, and box it's a composable function which can have items inside. Usually, when you use box, inside box you will use row row or column or different layout. What's the impact on upsize and compile time, if any? Of course, we will have impact on application size. Right now, it's really hard to say how big this impact, because it depends on libraries which will be included into your project. Because, as example, if you don't need animation, you can just avoid adding this library. However, speaking about compile time, I didn't saw big difference. However, the pretty important news here is that we have a preview function. We have a preview annotation. And in your Android Studio, you will have already rendered whole composable function. It means that if you add some changes, you don't need to install your application on device. Yes. And yeah, compile time a bit bigger, but we don't need it so often if we need it right now. So let's move to the next question. When building UI the classic way, the layout preview is a useful tool. Is there any equivalent for building with Compose? Right now, we don't have equivalent. We should write this code manually. However, maybe in future we will have something like layout editor. Speaking about layout preview, we have a preview annotation which help us to render our composable function. Yes. For navigation, have you tried it with a navigation component? No, I didn't try, and as I know right now, it's not working, but developer team announced that it will be fully compatible with a navigation component. And it will be additional version which compatible with navigation component. And it means that probably we will have situation when we have multiple composable function, and under the hood they used maybe fragment, maybe something else just to render such stuff. Today at 5 we also have discussion with one of developer from Google team, and I think it will be a great question how it will be implemented. Is like any predefined view like navbar? Yes, we have multiple views. It's up bar. It's called up bar, and we have view implementation. Top up bar like a toolbar, and nav and bottom up bar, if I remember correctly, it's something like navigation bar. The next question: if everything is drawn in Canvas, how you can do animation with a portion of the screen? Because all your animation connected with composable functions, and inside this composable function you can provide animation. Even right now you can find a super amazing animation built in with Jetpack Compose. I personally have no experience with Flutter, but talking with other Flutter developers, they told that it's pretty similar to what we have in Flutter. But yeah, it's rendered on Canvas, but animation can be applied to composable function. Do we need Android context when you write unit test? It really depends about what type of test we speak about, because if we test business logic, of course, we don't need to use Android dependency and context. If you want to test our composable function, I personally didn't try it, but I think if we need context inside composable function, inside testing composable function, we can use context ambient, and context ambient provide access to context inside composable function. I think that's all. Do we have any more questions? Thank you everyone. Thank you everyone who participated. I hope it was helpful. If you have any questions, just let me know, and I will try to answer all your questions. Thank you.